in an earlier lesson you learned about convection. Convection is the transfer of heat through the movement of a liquid or a gas that's being heated from below. Here we have a picture of a pot of water on a stove. The stove is the heat source. It's heating the water, and as the water is being heated, its molecules expand, causing it to be more buoyant. And as it becomes more buoyant, it rises up to the top of the pot of water here. Now, when it gets to the top of the water here, if it's not evaporated into the air above the pot of water here, it's going to cool down a little bit compared to the water down here because it's further away from the heat source. So, as it cools down, it becomes more dense, which means it's less buoyant now, and it's going to sink down. It can't sink straight down here because there's hot water rising up. So it gets pushed over and then sinks down towards the heat source again, where it gets heated again and rises back up. And this continues until either there's no more heat source or there's no more material to convect. This is how convection works. Now, I connected this to what's taking place in the Earth's interior in both the mantle and the outer core. Now, as you can see here in this picture of the Earth, this cross-section of the Earth, you have convection taking place in the outer core and in the mantle. First of all, this is able to work because the further inside the Earth you go, the hotter it is. So the hottest part of the Earth is the inner core. That's this yellow area here. The next hottest is the outer core, then the mantle, and then, of course, the crust is last before you get to the atmosphere. So here, the inner core is the heat source, and the outer core here, the outer core is liquid metal. Now, because it's liquid metal, because it's liquid, it's going to convect with this heat source below it. This convection in the outer core does something really cool. It creates Earth's magnetosphere. Okay? And so that's what we're going to talk about for the next few minutes. Now, the vocabulary term you need to know here, obviously, is the magnetosphere. The magnetosphere is Earth's magnetic field created by convection of liquid iron and nickel in Earth's outer core. You gotta make sure you have that in the glossary of your notebook. And some written notes for today on the magnetosphere. On the page in your notebook for the magnetosphere, you need to write at the top, Earth's magnetosphere protects life on land from deadly solar radiation. Without the magnetosphere, life on land would not be possible. Make sure you highlight magnetosphere, okay, since that's a word in your glossary now. Now, this is a drawing of the Earth with its magnetosphere, the electromagnetic field here, and the sun and the solar radiation and how they interact here. First of all, it's important to know that the Earth's outer core creates this electromagnetic sphere called the magnetosphere, because when you have metal circulating around other metal, you create an electromagnetic field. So the Earth has a huge electromagnetic field surrounding it called the magnetosphere. Okay? And what happens is the solar radiation from the sun goes directly towards the Earth, but this electromagnetic field here in pink is blocking it, and it's deflecting it around and away from the Earth. Now, there is some radiation it gets through, like ultraviolet light and some others, but most of the solar radiation is deflected away from the Earth. And because of this, life is able to exist on land. If there were no magnetosphere, then all the solar radiation would hit the Earth, and nothing would be able to live on land. Life would probably be able to exist in the ocean, especially in the deeper water, but not on land. Alright, so our vocabulary for seismic waves and the S-shadow. Seismic waves are vibrations that travel through Earth. Primary waves, the first seismic wave detected and moves back and forth. It's also called P waves for short. Secondary waves are the second seismic wave detected and moves side to side as it moves forward. Secondary waves are also called S waves for short. And the S-shadow is an area that S waves cannot be detected on Earth when there's an earthquake. Alright, so here are your notes for seismic waves in the S-shadow lesson. Primary waves can travel through solids and liquids. Secondary waves can travel only through solids. Because of this and the fact that there is an S-shadow when there is an earthquake, we know the outer core is a liquid. We also have learned what the rest of Earth's interior is made of based on the reaction of seismic waves as they travel through Earth. Make sure you have those written down on your page for the S-shadow and seismic waves. Alright, what you're looking at here is a diagram of the S-shadow. Here's the inner core, designated with an IC. Here's the outer core. This is the mantle, and of course the line here going around, that's the crust. When there's an earthquake, seismic waves travel through the Earth. Now, here, what I have drawn here are secondary waves, the S waves. And S waves, because they travel side to side as they move forward, they cannot travel through liquids. They can travel through solids only. And so what happens is the S waves move through the mantle, because the mantle is not a liquid, it's a semi-solid. And because it's not completely solid, the actual direction of the waves change as it goes through it. But here, the S waves, when it gets to the outer core, which is liquid, it just stops. And because it stops here, it doesn't pass through to the other side of the Earth. So when there's an earthquake, primary waves will go through here, and they can be felt down here in this part of the planet. Okay? As well as all over here. But the S waves can't, because they can't get through the outer core. Okay? And so it's just like if this were a ball right here, and I put a flashlight shining down towards that ball, we'd see a shadow right here. Okay? Same thing happens with the S waves. This area is called an S-shadow because S waves cannot get there. It's blocked by the outer core, the liquid outer core. Okay? And it's important to know this because this is how we know what the interior of the Earth is made of. The study of the seismic waves and how they travel through the different layers of the Earth tells us a lot about what it's made of. And this is how we know about the different layers of the Earth. And make sure that you draw this diagram